right, welcome to math for today. Last week we worked on, the last thing we did was finding hidden arrays in things. And that's a harder skill, so if you didn't get it right away, that's okay. We're going to be revisiting that quite a bit throughout the year. Today we're going to be kind of doing the opposite, and we're going to be adding to arrays. But before we do that, I just want to talk about being efficient. And we talk about that a lot in Mr. B's class, and I'm sure Ms. Keller does the same thing. Being efficient, it just means that working, getting to the same spot with doing a little bit less work. So here I have two different arrays. I can draw a line down the middle so we can see where they're separated. And here I have 3 times 4 equals 12, and I drew out the array, and I even have all the spaces in it. And that takes a lot longer to make than this one. Again, the same thing, 3 times 4 equals 12. And I should put a 12, like there's 12 there's 12 in here, and there's 12 in here. 3 times 4 is 12, but instead of drawing all the lines, I just use my mind and remember that they're in there. And I would have 3 rows and I would have 4 columns, but I didn't need to draw all of it. I just know that 3 and 4 is 12. So I'm not going to be using the arrays as much. If you need to, please do, but I'm going to be switching to from arrays to an area model. And I told my class this a little bit. I'm going to start using the word area model because it's just a little bit more efficient. I don't have to draw out as much. So I will be using the area model. And let's start with that problem right here. So we have, and this is where I'm going to show you where we're going to start adding stuff. We have 3 times 4 equals 12. And we're showing that 3 and a 4, and it's 12. So this is how we're showing 3 times 4 equals 12. What if I want to have the problem 3 times 8 equals, I don't know yet. So what I can do is I can take my equation here and I can double it because I'm trying to get 8 total rows. We know that we have 3 going this way, and they kind of like pretend they can even go out and keep going like that, our lines. And I have 4 going up and down. Again, though, I left those I didn't draw them, I did it in my head. I need 4 more. So what I could do is draw another array, and you can see that the 3 keeps going across, but I would add 4 more rows. So I put my 4 up there. And I'm going to clean it up here a little bit. We already know that 4 times 3 is 12. And this is still those 3's that go across. So it's 4 times 3 is 12 again. And what we did here is if I take these two numbers, they add up to 8 columns. So I got my 3 that are going across, and now I have my 8. I started off with 4, I doubled it, and I got 4 more. So now I have my 8. So now all I need to do is add my insides to get what 3 times 8 is. So 12 plus 12. Some of you probably got it before me already. We can always add. 12 plus 12 is 24. 24. So 3 times 8 is 24. Let's look at that again. I'm going to draw it out now as one single area model. 3 times 8 equals 24 is what we said. And I'm going to draw that out. And I have my 3, my 8, and my 24. Can I use this same thing to find 3 times 9? How would I do that? Think for a second. How would I find 3 times 9? Where am I adding something? Am I adding to my 3's? No, because we already have the 3 times something. 3 times 9, I need to add over here. So what if I just want to add a little bit like right here? Now I'm going to add 1 more. So now here, I'm trying to, oops, I forgot to erase this. We're trying to find 3 times 9, and what's that equal? So now I have my 8 and my 1, they add up, but I need to find out how many are in this box. And the way I do that is I multiply just like I did here. I'm going to take this factor, and I'm going to take 1, and I line them up like that. See how that goes? I go 3 and 1, and I line them up to right here. Those are my two factors. 3 times 1 is 3. And so to get 3 times 9, I just add 24 and 3. Add them together. I add my 1's first. I get 7. 27. So 3 times 9 is 27. A lot of you guys probably know that from just knowing your facts, but now you're actually showing me why it works. That's really awesome. All right, let's go back to my original one here. We had a 3 and an 8. Oops, I accidentally erased the 8. 3 times 8 is 24. What if I want to find this equation? 3 times 7 equals, I don't know. What can we do to our area model here? Well, last time we added one over here, that pretend one, and we put a 1 and it got 8, or it got 9, because we added 8 and 1. Well, we can't do that this time. What if we subtract 1? What if I take away 1 right here? So this is like a minus 1. So 8 minus 1 equals 7. And now I need to figure out what my minus 1 is. We already know that 3 times 1 is 3, but it's a minus 3 because we're getting rid of that chunk. So now I have 24 minus 3 equals 21. 21. So it's kind of a cool way that we're using our area model here to go up and down between the numbers, and we're showing it, which is really important. All right, I'm going to erase this again, and I'm going to go back to our 3 times 8. So we're back to our original 3 times 8. We've been able to find what 3 times 9 is. We've been able to find what 3 times 7 is. What if I want to find this equation? Now where am I going to add? Now where am I going to add stuff? Well, if we look at our factors and we line them up, our 8s, they're equal. We don't need to do anything there. But we have a 4 up here and a 3 here. So where are we adding? Are we going to add a column up and down? Are we adding one here? No, we need to add a row. So what I can do is I can add that row, and I put a 1 here. We're going to add 1 row because we just need to get from 3. We only need to go up 1 to get to 4, so I'm going to add a 1. And now we have to figure out how many is in this box. Is it 1 times 3? No, remember we line them up. So I go this number and this number across. And those are my two factors. So my factors for this box are here and here. And now I add up or multiply my factors. 1 times 8 is 8. And now this is giving me the problem because I added these two. 4 times 8, if I add up the whole thing, 4 times 8 is 24 plus 8 equals, start with my 1's, 4 plus 8 is 12. I can't put a 12 in the 1 spot, but I can put the 2 here. I can take that 10 and put it up there. You can even add the 0 above it if you really want, because I took that 10 and I added it up. Don't need to change it because that's 0, but 1 and 2 is 3. So 32 is our answer for 4 times 8 is 32. What if I wanted to do 4 times 9 now? So 4 times 9. So let's erase pieces of it here. And I'm going to write my new equation that I want to figure out. 4 times 9. And I'm going to change this into our 4 times 8 like we had. So I'm going to put my 4 here, And I'm going to erase these numbers. And what did we say that 4 times 8 was before? 32. All right. Now I'm trying to figure out this problem. Where am I adding it? I want you guys to decide. Am I adding 1 to the 4? Am I adding 1 to the 9? Am I adding a row? Do I have enough of those, or do I need to add a column? Where am I adding it? If you said I'm adding 1 to the 8, awesome job. Because look, our 4s match, but it's not matching here. So I need to add 1 more to get 9. 8 plus 1 is 9. Now I need to figure out how many go in here. So I take my 4 and I line it up with my 1, and I'm saying 4 times 1 are my 2 factors, or my factor pair, and 4 times 1 is 4. Then we can add these up, and I can actually do that in my head. 32 plus 4 is 36. 36. So, to recap, I know this video is a little bit longer than normal. To recap, we can add on different pieces to an original area model to get different equations to kind of help us out. We just need to be careful of where we're adding them. So here we add the groups, because these are groups. This is one group of 4. This is 8 groups of 4. They're just hidden. We don't need to see them all. Or this is 4 groups of 9 going across. But this is kind of a cool way that we can show how we add extra groups, or to just help us figure out what a different multiplication problem is. We will go over this in whole group, and there'll be some independent work you can use to practice on this. I will see you then. Bye.